Right. Good evening, everyone. Welcome to another class in blockchain new and tribute camp. And all these were right. We've been doing a lot of amazing stuff, writing smart contracts, learning about blockchain and all. But while it's one thing to write smart contracts, right, it's another thing to like build user interfaces that a normal user can interact with because don't expect your users to like head Twitter scan each time they want to like use your contract. So today we have a guest speaker here with us, Joshua Avoaja, a blockchain developer at Blockverse, and he's going to be taking us through the process of building beautiful user interfaces for our smart contracts, right? And I would urge us to pick in attention because very, very, very powerful assignment to be following afterwards. So please let's try to pay attention to the class. All right, Joshua, if you can hear me, I think you could please take over.
All right, yeah, perfect. I can hear you. So, good evening, everyone. Um, like Darlington mentioned, we're going over building building user interfaces for our smart contracts. So, this our talk is going to be divided in three sessions, basically. So, for the first session, we'll be looking at an introduction to ITAS. ITAS is a the library for building front ends. So we'll be looking at ITAS. So I'm going to be sharing my screen in a bit so we can just get started. Please let me know if you can see my screen. All right, cool. So let's go. So today we'll be looking at introducing what it does is doing basic introduction into what it does is and what. Sorry, can somebody not see my screen? Oh, okay, okay, cool. So we're looking at prerequisites like what software you need to set up your environment to build front end clients with Gitas or JS. Then we'll be taking a look at basic Ethereum concepts for using Gitas or JS. We'll be looking at Gitas or JS fundamentals, the fundamental things you need to know to use the library, and we would have an exercise which is supposed to last for I think about 40 minutes. So we will try to build a very simple front end client using it as a JS. Okay, so first of all, a front end client in Ethereum development or in development basically. So is the user interface that the user interacts with. So scoping it down to blockchain applications. So a front end client is the user interface of a decentralized application, and it is the part that users interact directly with, and it enables them to access Ethereum based services, to send transactions, to view blockchain data, like maybe displaying the balance of their wallet, viewing maybe custom data from maybe a smart contract you've written or something like that. And could also manage their Ethereum account directly from this front-end client. So in summary, a front-end client is basically like a gateway to um, Ethereum, an accessible and user-friendly gateway to Ethereum, to the Ethereum network. So let's assume you've written a smart contract to uh, let's just say a smart contract that handles decentralized voting, for instance, where users can maybe connect their wallet or use their decentralized identities to maybe vote on the poll or something. So say you've written your smart contract in Solidity. Now, really well, the smart contract can be interacted with without having to maybe click a button or fill an input form. But we know that not everybody can use maybe tools like Remix IDE, for instance, where you can just um, put in by the API of the contract, connect it to a particular address, and interact with the functions. So for accessibility and to make things easier for the end user, it's really important to build very usable front-end clients. Apart from maybe the UI parts, the UX also has to be intuitive. You have to make sure the language is has to make sure the language is understandable. You handle errors properly, especially errors that come from maybe interacting with the blockchain, because these errors can be very very vague. For instance, most of the time. So front-end clients should be very accessible, should be usable and accessible to make sure that the purpose of maybe your contract is achieved. So Ethers.js, like I mentioned earlier, is a JavaScript library that's specifically designed for interacting with Ethereum blockchain in front-end applications. And it provides developers with essential tools and functions to basically connect with the Ethereum network, send transactions and interact smart contracts, retrieve and display blockchain data. So Ethers.js kind of like simplifies Ethereum integration, and it makes it very very easy for very easy for front-end developers to build decentralized applications. So I think I added a tooltip explaining what a library is. And just for clarity, a library is like a toolbox for developers, and it's just a collection of code that has been written and functions and code tools that have been written and developed to perform specific actions. So instead of having to rebuild some functionalities or reinvent the build, uh, the maintainers of any library must have written, tested, and must have written and tested whatever library it is. And all you have to do as maybe a developer is to understand how the library works, so you can use it within your application. So although there's like a broader scope to using libraries and what library to use and what library not to be used for, um, that's like talk for it's not within the scope of this conversation. So um, the main purpose of libraries is to save time and effort on the part of the developer. And in the case of Ethers.js, it's helping developers save time and effort on developing dApps, developing blockchain applications. Okay, so to fully grasp what is going on here, so does anyone have any questions so far? Okay, so to fully grasp what we'll be talking about in this session, we're expected to have basic familiarity with blockchain technology. We're expected to have like a basic technical knowledge of JavaScript. expected to have a basic technical knowledge of Solidity. And of course, you should have a laptop with Node.js and npm installed, a code editor, and an Ethereum wallet like MetaMask, for instance, on your PC, on your laptop. Okay, so in case you don't have any of that, you can use you can use the links. You can use the links in the slide to download this softwares. If you don't have them, if you don't have them set up, so I'm sending the link in the chat box in case you need to download any of the software or tools that I mentioned. I talked about. Okay, so yeah, let's look at basic Ethereum concepts before going over to it as a shares. So I think so far you guys must have gone through writing smart contracts. So does anyone is everyone familiar with the concept of gas? So if you need maybe any further explanation into what gas is, you could just maybe indicate or something. So gas is like the unit of measuring computational work on the Ethereum network. So it's basically the cost of executing transactions. So maybe I don't know if any one of you have interacted with a wallet before, like a blockchain wallet before. When you try maybe sending out tokens or interacting with smart contracts, there are like specific fees you're supposed to pay to the validators on the network, and those fees are charged in the native token of the blockchain. So in this case, let's say ETH, Ethereum. So gas is what is used to measure how much computational power will be required to validate and execute a transaction on the block on Ethereum. Then gas price is the price per unit of gas that is paid by the sender of a transaction for miners, and it determines how quickly a transaction gets processed. So, say for instance, you're going to be spending a total of you're going to be spending a total of say 120 gas units, for instance, because gas is actually measured in weight. So let's say you're going to be spending um, weight GWEI, it's a unit for measurement in Ethereum. So the gas price is the price per GWE. So let's say the gas price is 0.000001 ether. To get the actual cost of gas in Ethereum, you'll have to multiply the gas times the gas price to get the actual cost of gas in Ethereum. So gas limit is the maximum amount of gas a user is willing to spend on the transaction, and it sets like an upper limit on transaction execution. So when the user is trying to send a transaction on the blockchain and they specify a gas limit, as long as there are no validators to process that transaction for that within that gas limit, the transaction is going to be pending. So that's why sometimes to speed up transactions, you pay more gas because it's the more you incentivize the network, the faster your transaction gets processed. So gas limit is sort of like setting a say like a stop loss, for instance, on how much gas you want to pay, setting a limit on how much gas you're willing to pay for a particular transaction. Then a transaction is a fundamental operation that can include transferring Ether, which is like Ethereum's native currency, interacting with smart contracts, or simply sending data between addresses. And transactions are signed by the sender's private key to ensure security and are recorded on Ethereum blockchain. Then the last Ethereum concept we'll be talking about briefly is APIs. So an API is a data structure that defines the methods and data structures of a contract in a format that can be understood by external applications and libraries. So APIs are mostly like in JSON, and they contain structure of what data should be represented as. So, for instance, for the example we have here, let me try to zoom in. I don't know if is it clear? The image I'm trying to show, is it clear? I see what I'm showing clearly.
Yes, sir.
Okay. So this sample API is like the structure of a smart contract that has a function, and it has a set and a get function actually. So if you check the set function, you see that the API specifies what should be the inputs, what should be the outputs, what's the name of the function, is the function payable or non-payable. At when if a function is payable, it means it can transfer ether. And for the set function, for instance, for inputs, you have the function is expecting a new value of type uint 256, which is like an unsigned integer, of 2 raised to the power of 2 raised to the power of, well, it's just an unsigned integer, sure. So it's expecting a new value, and this new value cannot be negative because it's an unsigned integer. So the then if you see the get function is also a non-payable function, but it has a state mutability of view, which means it doesn't write data to the blockchain, and it returns an output, but the output is not named. It returns an unsigned integer as the output, and it expects no input. So this is like what an API looks like. So it holds the data structure of the entire contract, from what functions are defined to what events are defined in the contract to what I think what modifiers. So an API it serves as a bridge between the Ethereum virtual machine, which is like what's popularly known as EVM, and the external world. So which means whatever programming language or uh, interface you're using understands JSON, it can basically represent data structure of the smart contract. So okay, about 1 hour, 30 minutes. So let's look at basic fundamentals for EthasJS. So the first one we'll be looking at is called a provider. Technically, a provider is a read-only connection to the blockchain, and it allows querying the blockchain state, such as getting the account of a connected user, getting block or transaction details, querying event logs, or evaluating read-only code. Now, for Ethers.js, a provider is separated from all write operations, and a provider is just like an instance that connects to the blockchain and can only read data from the blockchain. It cannot write data to the blockchain. So as stated here, all write operations are abstracted into the signal, so into the signer, sorry. So let's say if you work with other maybe other programming frameworks before, when you call something a provider, it's basically brokering connection between your client and maybe a server somewhere. So let's say, for instance, a you're working with Nextauth, for instance. For anybody that has worked in Nextauth, you're working with a database. The database provider could be an MSQL driver that basically provides a connection between your back end and the database. It's probably maybe hosted somewhere or hosted on your server. So in the case of Ethers.js, sorry, do you want to ask any questions? Hello, Henry. Okay, so a provider provides oh, so a provider provides or establishes a connection between your client and the blockchain for reading data only. Now let's talk about a signer. So a signer wraps all operations that interact with an account. Now for an account to be an account, it means that a private key is located somewhere. And this private key is used to sign any type of payload at all, a transaction, a message, anything at all. So in Ethers.js, a signer is an object that abstracts all operations that require authorizing authorizing anything at all, transactions, signing data that requires like signing stuff with the private key of the user. So a private key may be located in memory or protected via some IPC layer, such as MetaMask, such as maybe when you ask the user to connect their MetaMask wallet, for instance, to your application, you don't basically have access to you don't basically have access to their private key. Rather, MetaMask stores the private key in a secure location on their device and provides some sort of communication layer between your application and their wallet. So say your application wants the user to sign a transaction, for instance. Your application will send the transaction over to MetaMask. MetaMask, which is holding the private key of the user, will sign the transaction. We guide the user through the process of signing the transaction and return the signed data back to you. So in case you're wondering what an IPC is an inter-process communication. So MetaMask would act as an IPC layer between the user's account and your application. So a contract is like a representation of your a contract in JS is a representation of your of a deployed instance of your contract on the blockchain. A contract instance may read from the blockchain when it's connected to a provider, or can also execute state changing operations when it is connected to a signer. So when we are instantiating a contract, which I would see during the hands-on session, when we are instantiating a contract in JS, for instance, we have the um, we have the option to either provide a provider or a signer. So when you instantiate a contract with a provider, the contract can only perform read operations on the blockchain. But when you instantiate a contract with a signer, the contract can either read or write to the blockchain because it already has an instance of an authorized signer that can basically sign transactions. Do we have any questions up to this point? Are we like clear up to this point?
Sir, please repeat what you just said now, the last sentence.
What I just said about a contract.
Yes, what you said that when it is instantiated with a signer and when it's instantiated with an IPC layer or something.
Look, with a provider. Okay, so I was trying to say so we would see this in the hands-on session. But when you're instantiating a contract instance, apart from providing the API and the contract address, you can also provide either a provider or a signer. If you provide a provider, like the provider is what we described earlier, that establishes a read-only connection with the blockchain. So if you provide a provider while instantiating a contract, the contract can only execute read methods, can only read from the blockchain. It cannot write to the blockchain, it cannot change state. But if you provide a signer, the contract can both read or write from the blockchain. I don't know if that's clearer. If that's clear now, I'm golden. I think I should show you what I think. Let me just show you what I mean before we move ahead. Uh, let me pull up an example of instantiating with a provider or or a signer. So can you see my screen? Okay, so just what I was saying about instantiating with a, a provider versus instantiating with a signer. So if you notice, yeah, the die contract in this case was instantiated with the contract address, the API, and a provider. And after it has been instantiated, see the read-only methods that were called, got the name of the ERC20 token, the symbol, the balance of a specific address. But now to perform state changing methods, which is like writing to the blockchain, the contract had to connect a signer. The contract had to connect the signer. But in the beginning, the contracts could have also contracts could have also specified a provider, sorry, a signer instead of a provider. So that's what I was trying to explain between like when you connect the provider to a contract versus when you connect the signer. So I don't know if that's clearer now. Okay, so let's move on. So when transactions have been submitted on the blockchain, a receipt is issued after the transaction has been included in a block. So a receipt is like the blockchain's way of telling you, okay, after performing, of course, all transactions are state changing. They are right operations. So after performing a transaction on the blockchain, a receipt is just the blockchain's way of telling you, okay, hey, here is information about what you just did. This is the block, this is the transaction hash of the transaction. This is the block number in which the transaction was included. This is the gas that was used. This is what was sent, if ether was sent, and these are the events that were emitted. So a receipt is just blockchain's way of telling you, okay, um, you've done this. Here's feedback on what you've done. Here's some feedback on what you've done. So okay, so that's basically it on the fundamentals of data suggest. Actually, those are like the key things we need to look at today. So, like I said, this session is divided into three parts. So for today, I think we're just going to go straight to the hands-on exercise. I'm assuming everyone is with their laptop. Okay, cool, cool, cool. So, just to get you started easily, I'm going to push. I'm going to push my repo on GitHub and send you a link that you can clone. So it's basically just a React app that was bootstrapped with Byte. So with Byte and Tailwind. So just give me a minute. Let me push this. Sorry, just go ahead, please.
So are we supposed to code along?
Okay, no. I just need to put this together so I can push it. Then we you just clone the repo. Then we can follow along from what I have here.
All right.
Yeah. So just give me like 5 minutes. This. Let me push this on GitHub. Okay, so I'm going to stop presenting for a while. So I will if you have any questions from what we've discussed before, for now, so I think you could um ask them. Okay, so I dropped a link in the chat box. So please clone the repo and let me know when it's done. So that's if you want to follow along with the if you want to follow along with on your own laptop. So you could just load the repo and follow along. Then you could also follow from my screen too. So we have a basic layout of a React app that will be um, connecting blockchain to. So I'm just going to go ahead to follow the documentation for on ethers.js and install ethers. Sorry, can you see my screen? All right. So I have npm installed. I'm just going to go ahead to install it as a my React app. So if you crunch the repo, you would see two components there. One of them is an account component. The other is a connect wallet component. So what we want to do is we want to provide a wallet connection in the connect wallet component. So we'll be doing something very basic actually, using Windows.Ethereum. So one more thing, sorry. I need to update. I need more state here. Let's output here. So I want to be able to store the. I want to store the. I want to store the signer. Let's store the signer. I want to store the signer. Okay, so let's just fix a couple of these errors. Let's fix. So what's it? 300 existed window and type of about this. Well, let's see.
Sorry, please, can I ask a question?
Yeah, just go ahead.
Please, what extension do you use that is getting the errors for you there on the?
Okay, so this is actually linked. Because I have TypeScript installed, so TypeScript actually has like some of these type checks, and this particular one is linked. So it's not like a particular extension because VS Code actually like automatically supports TypeScript. So with an ESLint configuration, it automatically fixes errors and highlights them. But if you're looking for a syntax highlighter, I think you could install SonarLint. Let me see if I'm getting the name correctly. Yeah, SonarLint. So I dropped the name in the chat box. It's also good for identifying like errors in your code.
Thank you.
Yeah. Okay, so what we're basically trying to do is to instantiate a Web3 connection in our React app. And we're trying to do that using window.ethereum. And window.ethereum is an object that is usually injected by most crypto wallets. So say for instance you have the MetaMask extension installed on your browser, for instance. So every time you load a web page, MetaMask injects this a script that basically sets window.ethereum. So if you're trying to instantiate a connection, your browser, your web page has access to window.ethereum. Sorry, somebody had their hands up.
Yeah, please, can you? You said you were going to update your repository. Please, can you do that?
Wait, I pushed like the base files already. Did you see it?
Yes, I've cloned that one already, but this particular changes you made now, you said you were going to push it.
Okay, so it's not live, right? Like this is on my
Mm,
local machine. So I was saying that you could follow like this, you could follow me like this, or you could follow on the call, or you could try like what I'm doing on your laptop using
all
the
right.
base files I provided. Yeah. See. But at the end of the session, though, I'll update the repo at the end of the session with whatever changes we make on the call, like as we're on the call. So if you understand like basic React state stuff, you know that I just want to be able to save like the signer and the account is like the user's address to state. So it doesn't clear off when I can just store it somewhere and reuse it. So so what we're basically trying to do now is to have access to the Windows.Ethereum instance that must have been injected with a I must have been injected with a what's it called? I was injected by maybe MetaMask or any Web3 browser. So let me just add a check that basically alerts the user. Then let me find a way to fix this error. So I'm basically just going to update like my byte env so it can recognize window of Ethereum. I think that's what it said fixes the error. Yeah, that's what it said fixes the error. But let me try this. Does this exist? Does this exist? Okay, so we have cleared up the error. Let me see. Where's the error? Okay. Yeah, cleared up the error. So external provider or undefined is not assignable to the okay. I see. Okay, so I don't want to do this, but I guess we just have to do this because I installed the. Come on now. So just so we can move ahead, I'm just going to bypass the error so we can move ahead and just spend the entire day trying to fix whatnot. So I'm going to pass one more thing to account. I think I should just pass the signal instead. Hold up, hold up, hold up. Be serious. Wow. Okay, oh, so I think, sorry, I think we're trying to instantiate the wrong type of provider here. Sorry. Are we? Wait. I should test to see it prompts the print of the MetaMask prompt. So let me run this. Okay. So yeah, so that actually brings up the MetaMask prompt, but mine is so big, so let me just read it. Yeah. Brings up the MetaMask prompt and it's asking me to sign into my wallet. So let me just do that. Approval to connect, and yeah. So please forget about the UI, but um, up to this point, we've been able to connect and connect. Up to this point, we've been able to connect this thing, connect our front end to an Ethereum wallet. So the next thing is we now have an instance of a signer that we could use to say connect the contract and interact with the contract. So before that, let me let me make this look a little bit better. Let me make this look a little bit better. So it's, our lockout function basically just resets the signer and the account to undefined. Okay. Yeah. So because I have actually connected my wallet, it's not going to so the MetaMask prompt is not going to come up again. So let's just make our accounts components look not so bad. Right. Yeah, so let's add some space. So when the user, let's see, um, let's try it differently. Let's also store an instance of the provider um, because we might be needing it for stuff. user, let's say we are going to be using the get balance method of the provider. We're going to be using the get balance method of the provider to get the user's ETH balance when they connect their account. Okay, so we want to get balance for the account that's connected. And it's the balance. Then we're going to call this function the component mount. Okay, so let's see. So we're supposed to convert the balance to let's convert the balance to because the balance is usually in big integer. So we're supposed to convert the balance. Yeah, that's the function. Okay, so sorry, let's use this as a string. So let's say we want to add the balance somewhere. Let's just add that. Let's just add it somewhere. Just add that somewhere. Okay, let's see. Another wallet. Okay, so this is the amount of Ethereum the wallet I connected has. Let's confirm from MetaMask. Okay, so this is rounded off actually. This is rounded off 0.009. This is rounded off to this thing. This is rounded off to three decimal places. Yeah. So, okay. Then, are we following up to this point, or are there like some things you want me to go back and explain? Hello, can everyone hear me?
So, if you can like explain the functionalities of your code, it will help us better.
Okay, okay. So, I just wanted to get through it technically so I can start, I can explain as it works. So let me go over this process again, or let me just go over this process now that we have like the baseline technicals laid out. So I'm just going to disconnect my account from here so we can go over this process again. So um you understand React, yeah? React is not the problem here, Abby.
No, sir.
Okay, cool. So importantly, can you see the connect wallet function?
Yeah, yeah, yeah.
Let me see. So I explained earlier that when you have say like an extension like when you have an extension like MetaMask in your browser, for instance, it injects an object called window provider, which is an interface MetaMask provides for your tab to interact with the user wallet. So to get the prompts to connect their wallet, yeah, we're basically going to be instantiating that the window of Ethereum that MetaMask has provided us with as a browser provider using the ETAS library. So now, importantly, we imported ETAS, and we are creating a new provider using the new ETAS provider, ETAS provider, the new ETAS provider constructor, passing passing the window of Ethereum that MetaMask has provided us with. So here's the flow. Yeah. Okay. Sorry. You just go ahead and ask the question.
Okay. The provider now in this case could be, let's say, our server. That's our backend server that's trying to read information from the blockchain, right? Or a client trying to maybe get information from the blockchain too, right?
Well, in this case, our provider is our connection to the blockchain, like I explained earlier. It's the connection to the blockchain. So we are trying to create a connection to the blockchain using MetaMask. We're trying to create a
Oh,
connection to the blockchain in our application using MetaMask. Is that clear?
yeah.
Yeah. So the user already has a wallet on maybe an extension like MetaMask. So we want to make use of that extension to establish a connection with the blockchain and also get the signer that we can use to request authorization for transaction. So the rest of what's going on here is just us trying to set stuff to state. But most importantly, these are the two important things that we're paying attention to. We're creating a provider, which is a connection to the blockchain, and getting the signer that is attached to that provider. And the signer is, in this case now is the user's MetaMask wallet. So if you go back to the UI, you can see that there's a button to connect your wallet. So when you click on connect wallet, it brings up the MetaMask prompt. Can you see the MetaMask prompt?
Yes, sir.
Good. And it asks me to confirm that I want to connect. It asks me to approve my connection to the tab, which is like on my local host. See the link to the tab here. So when I connect, you can see that it loads the account component I talked about. This is the address I connected with. Now we use the provider to get the user's balance in Ethereum. So I'll show you how I did that. So using the provider that we set here and that we passed into the account component. When the account component loads up, they're using the get balance method of the provider to get the user's ETH balance. So remember that when we inserted this, the prompts are passed into this component. We pass the provider, we pass the account that was connected, which is this address. We pass the provider that we created, which is the provider here. The provider we created using the user's MetaMask wallet, and we pass the signer, which is the signer we got from the provider here. So inside the account component, we're now basically getting the user's ETH balance, we're getting their balance, and the balance was returned in big int. So remember that in Solidity, for instance, most of your numbers are either specified with an unsigned integer. So when the number gets sent to like your front end, yeah, it's going to be like a big integer. And GS has utility functions to convert big integers like regular numbers that you cannot display on the front end. So here's what I'm doing. I'm getting the balance, which is like in big int. As you can see, my VS Code is telling me the type of balance. It's a big integer. Then next thing I'm doing, let me break this down into steps. The next thing I'm doing is format the balance as a regular number. Now, because the result of this formatted balance is a string, I need it to be a number so I can round it off. So I am passing it to like the passfloat function. I'm passing the string to the passfloat function and rounding off the balance to three decimal places, as you can see on the UI here. So the major thing is us getting the balance of the users of the native token of blockchain using the get balance function on the provider. So as you can see the description on the function, get the account balance in way of an address. So the address we are providing is the account, this guy here that we got from connecting to MetaMask. So is that clear now? Like what we've done so far, is it clear? Or is there any other thing you want to clarify on?
I'll ask questions later. Or anybody.
You ask questions later.
Yeah.
Hello,
Okay,
sir.
cool. Yeah, hello.
Okay, sir, we got our provider, which is our MetaMask, right?
Yeah, because our provider is in MetaMask, yes.
Okay, so but then it's like you got the signer too from the provider again.
Yes.
Okay, no problem.
So like I explained earlier, a signer is like the object that is allowed to authorize transactions. So this our provider here is just a connection to the blockchain that can read data only or cannot sign transactions. So because I anticipated that we'll be needing the signer as a moving forward, so I just got the signer here and just set it to state. That's all I'm doing.
All right, sir.
One more thing, sir. Is MetaMask the only provider that can connect to Ethereum network?
No, MetaMask is not the only provider. So I have MetaMask on my laptop. You can have maybe I also have Coinbase on my laptop too. But since I'm using Windows Ethereum, it picks up whichever one was injected into the script, for instance, into the page. So remember that the provider we're creating, we're using ETHAS to create it. But to create like the provider that ETHAS understands, we need we need the provider from MetaMask. So let me see if I can explain better. So if you check my MetaMask wallet, for instance, MetaMask wallet I have, we see that it's already connected to the Ethereum blockchain. That means it has already established a connection to the Ethereum blockchain. So to enable Ethers to use that connection, yeah, we are now going to use the provider MetaMask provides exposes to our dApp, to our front end, and use it with the browser provider constructor that it has. So if you're going to, what you need to do is give it a provide blockchain already. So in this case, the wallet house is already connected to the blockchain. We don't need to instantiate another connection to the blockchain. Rather, we are extending the connection so that we can use ethers to use it within our application. Okay, see it this way, yeah. You have a generator that is on already, yeah, and you've connected power to the house. Now you're inside the house. Do you go to plug maybe your phone directly to the generator, or do you plug it to maybe a socket inside the house?
Sorry, come again.
I said you're using a generator, for instance. You powered on a generator, which in this case is like our MetaMask provider. You've powered on a generator and you've connected it to say your house. And if you want to maybe charge your phone or you need access to the power, you don't need to go directly to the generator, but you can actually connect maybe like a socket inside the house. Is that correct?
Yeah, yeah.
So what I'm basically saying is the MetaMask wallet we have has already established a connection to the blockchain. As you can see here, it's a functional wallet that has been connected to Ethereum, for instance, and it's already performing all the actions, reading the balance. I can do everything I can do everything I can do with the wallet here. So now to provide that disconnection to our dApp, instead of creating another connection to the blockchain, maybe by providing our own RPC or something, we can just directly connect to whatever the wallet is connected to. That's why we are passing Windows.Ethereum to the browser provider constructor here. Remember that this Ethereum here is Windows.Ethereum. Let me just write it down just here so it's clear.
Okay, just I'm just imagining, sir. Can we like connect directly to Ethereum without MetaMask or any other provider?
So if you're going to connect directly to Ethereum, for instance, you can use like say Alchemy, for instance, as a provider. But then to be able to sign transactions, you need a wallet. I don't know if that makes
Okay.
any sense. Yeah. So the reason why we're able to get a signer here is because the provider that is connected already was connected with, has been connected with a wallet. But we can create our own provider, say like Alchemy, for instance, using Alchemy. But all our this thing is going to be able to do, it's just going to be able to read data from the blockchain. It can't write data to the blockchain. Let's, I think, should we try that?
No, I'm just imagining. I still have another imagination. Sorry, but I think can we can create our own wallets, right? Like customized wallets using Solidity, right?
Yeah, you can create your own wallet so long as it conforms to the so for instance now if you check to extend a provider, for instance, you have to provide a specific type of provider. So long as the provider your wallet is exposing conforms to this EIP 1193 provider, okay, let me just let me show you something on that real quick. So it's like a standard that was proposed for wallet providers. So long as your wallet provider conforms to this provider, you can build your own custom wallet and connect it to Ethers.
All right, all right.
Hello,
Okay,
sir.
so yeah, okay,
Sir,
I can hear
okay,
you.
you were saying something initially. You said that our MetaMask is already connected to the blockchain, that we want to extend the connection of that
Yeah.
MetaMask to our dApp. Then you were now saying something about Windows.ethereum. You were explaining something there, then you now stop. Please continue from there.
Okay. So I was saying that MetaMask, for instance, exposes extensions like MetaMask or wallets like MetaMask expose the provider to your dApp, to your web app, to your web application using Windows or Ethereum. So if I go to where we are serving that application, I think that should be localhost something something. Let me check. Yeah, this is it. If I inspect this guy, uh, guy, where's this guy? Where's this guy? Okay, good. So see the sources, for instance. Can you see like a MetaMask folder? Can you see a MetaMask folder? So
Yes,
inside
sir.
the script, yeah, so this script is used to inject Windows.ethereum in our web page. So remember that what I'm inspecting is our web page. See it here, localhost 5173. But because I have the MetaMask extension installed, it is injecting this script into every web page I open in the browser. Does that make any sense?
Yes, sir.
So you can see where it's assigning you can see where it's assigning Windows.ethereum here inside the script. So because I have MetaMask installed, if I uninstall MetaMask now, I won't have access to Windows.ethereum. If you check Coinbase, I think Coinbase does the same. The Coinbase extension does the same thing too. They inject what is it called? They inject your browser with Windows.ethereum. I'm sorry, inject your web page with Windows or Ethereum. So you have like an instance of a connected wallet available in your web app. Let me close this. Yeah. So, do we understand what's going on up to this point? So, I don't know if you noticed what happened. I was asked, I was part of the prompts that came up on my laptop now was asking me which wallets that I want to use, whether I want to use Coinbase or MetaMask. That's because I have both extensions installed, and both of them are injecting their own window of Ethereum for my to my web app. So we are consuming window of Ethereum using the browser provider constructor that it has in the library. So can we move ahead? We have like 15 minutes more. So let's see if we can maybe try sending a transaction on the blockchain or something. Maybe sure I'll have enough for gas here. So let's just do this directly in the account. So I'm just going to go ahead and create a function to transfer let me see. Do we transfer um let me see. Okay, let me switch. Let's just do something very basic, child. So it's not because I wanted to actually show like connecting to a contract. Or maybe we'll do that like in the next section. But for now, let's try to send a transaction using meters. So I'm just going to create a function. I'm going to create a transfer ETH function. It's going to accept an amount, number, and it's going to accept a destination wallet. Let's just use a string. Let's use a string. So let's head over to Itastock. Let's see how we can create a transfer transaction. Why it blah 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 sending transaction. So we can send transactions using the signer that we have already. Like I said, the signer is actually required to authorize transactions on the blockchain. sent to the destination wallet, and waiting for. So we're basically going to be converting this guy to a big integer. So most of the time when you're working with a front end client that basically sends data to maybe a smart contract or the blockchain, you'll be needing to convert your numbers to big integers. Already has like functions for data, which is basically going to convert a number, our amount. That's going, in this case, this is going, which is like the for a six decimals. We'll be using something like a pass unit where we can specify the number of decimals. So, but in this case, you're transferring Ethereum. So, let's leave it at Basida. So, our function to transfer Ethereum is basically sending a transaction. So, our connected blockchain, specify the destination wallet and the amount we want to send. So, let's see. And allow something here. So, we allow the log rate to become the transaction hash, a hash, transaction hash. So, do we understand what this function is? Like from looking at the function, do you understand what the function is going to do? Can anyone hear me? Hello.
Yeah, I can
Hello.
actually hear you. I have no idea why they're not replying.
Okay, so I hope like I just want to be sure that they're able to follow up on like what I'm saying and it's not too complicated at the moment. So I don't know. I would
Yeah,
really want that feedback right now.
I
Yeah.
think it's their first time, so I don't think I expect them to follow everything at once. But then, as always, we're going to make the recording available, and they can always reference it afterward for probably to get a better understanding of everything that's going on in the class.
Okay. So in that case, I actually just want to round up the session with just maybe showing like what transferring Ethereum looks like. So I don't know if you guys remember the signer we got when we when we initiated the wallet connection. You remember the signer, right? The guy that has the ability to authorize transactions. Okay, cool. So we are going to be using that signer in our account component to send a specific amount of a specific amount of Ethereum to a destination wallet, to a wallet that would specify. So I'm just going to go right ahead to create like a simple form just below this. Just going to go ahead and create a simple form just below this. Um, Let me see what that looks like. Okay, so we have our inputs. Let's see. So we need another input for the address. Then a button. Okay. Hmm. So let's add a submit handler with the we can use to process the transaction. So yeah, we need to keep track of the amount input or what's the easiest way to do this? Remember that a bulk of what I'm doing is actually React really. So we can interact with like the we can interact with the content. But the major thing that we actually needed to do here was just the signer to send the transaction. So this is just to provide an interface for making those clicks and providing an input. Okay, so we once have everything ready, then we're calling the transfer ATH function. The amount and the destination. Let's just use a regular string here. Okay, so I think we have everything hooked up to make our transfer work. So again, this is important piece of the this thing here, transfer ATH function. Every other thing is just for interaction. So we're using the signer to send transaction to a destination wallet, specifying the amount we want to send, while converting the amount to a big integer. So this let me add this here. First convert amount to a big integer, a big int. Okay, so let's try it out. Um, connected our wallet. I don't have so much, so I'm going to try to see if I can send as low as that. And I'm going to be sending this to. Can anyone just like maybe provide their wallet or something in the chat box and EVM wallet? Can you guys hear me? Okay, I think I'm just going to go ahead and use my uh, send.
So two people just posted their wallets.
Yeah, I did not get that.
We just posted our wallets. What are you
Where?
typing?
Oh,
Sorry.
oh, 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 oh! I didn't see that. Okay, I've seen it now. So I'm going to send to Somto. Anyways, this is not worth anything, sha, but let's just use it to test what we did. So you notice that it's asking me to authorize the transaction in MetaMask. So MetaMask is going to estimate, okay, oh, I have enough gas to cover. Wow, surprisingly. So I'm going to confirm the transaction. Then, of course, there's no loading UI, so you won't see that. Okay, so here we go. So this is the transaction hash for the transaction we just sent. So if I go to say Etherscan and open it and create one, Etherscan DX. Hold on, hold on, hold on. So wait for at least 30 seconds for refreshing the page. Okay, so I think, wait, sorry, let me confirm something. Wait how much this transaction I just sent. Yeah, hasn't confirmed now. Okay, let me just view on Block Explorer from here. Oh, oh, I'm connected to, okay. I think I'm connected to optimism. Okay, connected to optimism. Connected to optimism. So yeah, connected to optimism. So this is like these are the details of the transaction I just sent from my wallet to the wallet Somto provided. I think you can check that to confirm. Let me just send this here. It's just $1 anyway, $1.41. So on optimism actually. So we've been able to use ethers to basically read the yeah Santo. Just go ahead.
Is Optimism another testnet like Sepolia, or is it the mainnet, Ethereum mainnet?
It's a mainnet actually, but it's a layer two.
Layer 2. I've not heard that before. Please, can you explain?
So in the EVM space, layer twos are like are networks that are built to optimize the performance of Ethereum. So they don't process transactions on Ethereum because Ethereum has like a low TPS, but they process transaction on their own network they rely on Ethereum as for security, business transaction on their own network, and send what's it called, and send already confirmed transactions to the Ethereum network.
All right.
So it's just like a blockchain you can connect to. So do you know that Ethers is not just doesn't just work for Ethereum. It works for every EVM compatible network. So I remember I mentioned something about EVM at the Ethereum virtual machine. So anything you do on Ethereum can be replicated or done on any network that supports EVM. So I think for our hands-on session that would be all. So I we were able to use the basic stuff we discussed earlier in this as provider, the signer, and receipt. So we did not get to the contract part because of time. So we used the provider to get the user's balance. As you can see here, my balance is now zero. It's rounding up to zero. Yeah. I've sent most of what is there. We use the provider connection we created. Use the provider connection we created to get the balance. We use the signer to send um, transaction, which is what we just did now, and we got the transaction hash via the receipt. So the receipts that was returned here. So I think that's going to be all for our first session. So as we move on, we're going to go in depth into using it as for more complex stuff.
Yeah. So please don't forget to post the code. I mean, sorry, upload the code.
Sure. Then sorry, Darlington, are you here?
Yeah. I'm here. I'm here.
Okay, so where can I send over the slide?
Yeah. Please drop it on the group chat, the Web3 group chat. I'll nick
Okay,
it. I can see something is also asking like you send the link to the code base too. Um,
all right, cool. I'll do that.
yeah, thank you so much, Joshua. I guess it was an amazing session. Please, guys, I'll be uploading the recording as soon as I get it right. So don't fret if you don't understand everything. Just try to go through the recording, and I'm sure like you'd get it with time, right? Thank you so much for staying till the end of the boot camp. Already like we behind schedule. So I think that would be the end of it. Good night, everyone.
Yeah. Good night, sir. Thank you.